Good evening, all. Welcome to Unacademy. Pawan, good evening. Sai Teja, good evening. Pawan, Sai Teja, ready. Yes, Josna, good evening. So let's wait 2 minutes, then we'll start the session. How are you all? Am I audible to you? Is my voice clear? Okay, please comment about my voice. Is it clear or not? Okay, ఇనిపిస్తుందా అందరికి? Yes. Okay. Vishnu, good evening. Sai Teja, very good. Bhargav, good evening. Pawan Kumar, that tomorrow have class in Unacademy? No. Monday we have a class. We have a special class on Monday. Pawan, I will inform you before the class. I will inform you. Good evening, Nageshwar. Okay. For new learners, let me introduce myself. This is Bhanu Prakash, expert in GATE and ESE coaching. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience and I train many students throughout our country for different competitive exams like GATE, ESE, Transco, Genco, and also many more competitive exams, that is the State Electricity Board exams. And also my subjects are electrical machines and power electronics. The BPC10 is my code. Okay, this is a BPC10 is my code. If you use this code, you will get 10% discount on Unacademy Plus subscription. Okay, got it? So Vijay, good evening. So what are the subscriptions? Okay, there are the two subscriptions. One is the Plus subscription and second one is Iconic subscription. The benefits of the Plus subscription: one is live classes from the top educators and structural schedule. Okay, you can plan your schedule for 3 months, 6 months and also 12 months and 24 months. Okay, if we know the structure schedule, the preparation plan will become very easy, and also unlimited practice questions per topic wise and also subject wise, and there is a availability of the test series. Okay, so this is a very important role to crack any competitive exam. And one more subscription, that is Iconic subscription. So in addition to these four benefits, so you will get another four benefits if you take Iconic subscription. And what are the benefits? One is the we will assign one personal coach. So he will guide everything until you get a job, or if you want to do MTech from IITs and NITs. So he will guide everything until you get admission into the MTech in IITs and NITs. And also we will provide study planners. So exactly what is the preparation plan, and also we will provide like which subject we have to read initially, and after that the what is the order of the subjects to be read, okay, per competitive exams like GATE and ESE. So this will also we will provide. And next one, expert guidance. Okay, you will get expert guidance, and ESE mains question and answers. Okay, so also you will get practice questions for the mains and also answers for every practice questions. These are the benefits of plus subscription and also iconic subscription. Okay, got it? And next one, what about payments method? This plus subscription is available for 6 months, for 12 months and also 24 months. For 12 months, the fee structure is a 25,000 rupees. So if you use my code, that is BPC10, you will get 10% discount. So after the discount, how much you have to pay? It is a 22,500 rupees. Got it? And this iconic subscription is available for 12 months only. For 12 months, the fee structure is a 45,000 rupees. The BPC10 is my code. Use this code, you will get 10% discount. So after the discount, you have to pay 40,500 rupees. And what about the payments methods? So we can pay by using any EMI cards like ICICI, HDFC, Axis, Kotak, and for 3 months EMI, the fee is 7,500 rupees per month. For 6 months EMI, fee is at 3,750 rupees per month. For 9 months EMI, the fee is at 2,500 rupees per month. So for 12 months EMI, fee is 1,875 rupees. Okay, got in point? 1,875 rupees per month. Okay, this is a per month fee. Okay, if you use my code, you will get 10% discount. So this is only, okay, here these prices up to 20 of this month. Okay, 20 of this month only. After that, so this price is going to be high. So that's why if you want to take the subscription, take it as early as possible. All of you got it? So if you want to take the subscription, take it immediately. Okay, before 20 of this month. After that, this fee will become double. So it is a very expensive for you. Satish, Raju, Joseph, Divya, good evening all. Okay, how are you? All of you got it about this fee structure. మీకు సబ్స్క్రిప్షన్ తీసుకోవాలంటే కంపల్సరీగా 20 ఆఫ్ దిస్ మంత్ బిలోనే తీసుకోండి. తర్వాత మీ ఫీ స్ట్రక్చర్ అనేది ఇంక్రీజ్ అవుతుంది. ఇట్ విల్ బికమ్ డబుల్. సో దట్ విల్ బి ఎక్స్పెన్సివ్ ఫర్ యూ. Okay, got it? Very good. Is that clear, everyone? Okay, listen. Today we will discuss about one of the important and one of the difficult subject in the electrical side. So that is a power electronics. Okay, very the interesting subject in the electrical side. Power electronics, got it? So in power electronics subject, so initially I divide this subject into the 5 chapters. So first chapter 1 is a power semiconductor device, and second one is a AC to DC converter. Okay, this is nothing but AC to DC is a the rectifiers. Okay, that is uncontrolled rectifiers and also controlled rectifiers. Next one, DC to DC converters. Okay, DC to DC converters means, so that's we call the choppers. Okay, that is we will discuss all the chopper circuit. So that is the buck converter, boost converter, buck boost converter, and current commutated chopper, and also voltage commutated chopper. Every part we will discuss the very clearly. And next one, DC to AC converters. Okay, this is nothing but the inverters. Okay, inverters or power electronics. Okay, next one, AC to AC control converters. So these are the frequency converters, just like a cyclo the converters. Okay, this is the cyclo converters, got it? So here the rectifiers, inverters, and also cyclo converter, and one more part is also there in AC to AC converters, that is a the AC voltage controllers. Okay, how do we control the output voltage? So that we discuss in case of the AC voltage controllers here. So this is about the core structure. But which chapter is a very important for competitive exams? This is a very important part. Suppose here power semiconductor device. So this is nearly, so this part is a nearly 25% of the this is the 25, the 20 to 25%. Okay, this one is the 20% of the power electronic syllabus. Okay, so this power semiconductor means most of the, yeah, 20% of the question comes from this part. Okay, and next one, this part AC to DC converters. So this is a nearly 30%. Okay, this one is a 30% of power electronics. Okay, yeah. And similarly, DC to DC converters. Okay, it is also 20% of the power electronics syllabus. And next one, AC to AC converter. It is a the 20% of power electronics syllabus. So remaining 10%. So that is the fundamentals of the AC drives, DC drives, and also cyclo converters, AC voltage converter, and also one more chapter is also there. That is a, so this is the basics of the drives. Okay, that is completely the 10%. Okay, like this, the 10% of the P here, including the drives part. So these four chapters are power semiconductor device, AC to DC converter, DC to DC converter, and also DC to AC converter. So these four chapters are very important for GATE and ESE point of view. Okay, all of you got it, my point? Is getting echo? Okay, let me see once. Okay, now is it clear? Vamsi, Satish నేను బాగున్నాను. మీరు ఎలా ఉన్నారు? Vamsi Moli, clear Anna. Okay, thanks for calling me Anna. Thank you, bro. Now is it clear right now? Tell me. Just wait a minute. Now, ఇప్పుడుందా ఇంకో? Is it clear now? Yes. I think Okay, ఇప్పుడు okay. Okay, thank you all. So this is about the course structure, power semiconductor device. So it is almost equal to 20% of the PE syllabus. AC to DC converter, that is a rectifiers, and DC to DC to DC converter, choppers, DC to AC converter, inverters here. And one more, that is a AC to AC converter, that is cyclo converter, AC voltage controller. So it's a nearly 10% of the P. The remaining complete, this is the syllabus structure here. And weightage point of view, how many marks you can expect from this chapter C? So what is the weightage? So here the weightage of power electronics in competitive exams. Okay. So this is a, okay, all of you got it. So weightage of this subject in the different competitive exam. So in case of the gate exam, so we can expect, okay, it is a 8 marks to the 12 marks. Okay, this is the in gate point of view. Suppose in IES, so in there are the two papers. Okay, here in paper 1, okay, paper 1. So yeah, that is prelims. You can expect that is a 20 to 25 marks. Okay. And in paper 2, so that is a 80. Okay. This one is a 80 to 90 marks. Okay. Out of, okay, 300 marks. Okay. This is a, so in case of the paper 1 and paper 2 here. Got it fine? So this is about the weightage. And what about the reference books point of view? So for this reference books, see here, okay, reference books. Okay, one is a, this one is power electronics. So by PS Bhimra. Okay, this is the PS Bhimra. And second one is power electronics. Okay, by is a Rashid. Okay, this is also one of the good book. Okay, and another one, power electronics by the PC Sane. Okay, this is also, the three books are enough for the reference point of view here. Got it? So my notes is enough. I will clearly give the notes. Don't worry about the reference books. Okay, first attend my class. You will get the notes and lectures very clear and very detailed manner. Okay. Yes. Suppose in the transco, and suppose if you want to prepare for the transco or the genco point of view here. So in this case also you will get nearly 10 to 12 marks. Here this is in case of the transco and genco, state electricity boards, and it is in case of IES and gate point of view here. So you can expect 8 marks to the 12 marks. Okay. The syllabus point of view, these are 20%, 30%, and also 20%, 20. And mostly here, the miscellaneous topics and AC to AC converter, that is a 10% of the PE syllabus. Okay, all of it clear? Is that clear, everyone? So let's proceed about actual discussion. Okay. So in power electronics, there is a first question in our mind, why power electronics? Okay, there are the some questions like why power electronics, and second one is a what is power electronics? Okay, and third one, what are the advantages of power electronics, and what are the advantages of the disadvantages of power electronics here. These are the four questions. So one is why we have to read the power electronics subject, or why it is more important for the electrical side. And another one, what is power electronics? Okay, third one is a, so what are the advantage and what are the disadvantages of power electronics? And one more is a, so that is a, what are the applications of power electronics? Okay, this type of question will ask in the interview side or any the computer exams also. So first let us discuss the first basic question, why power electronics here? Okay. So power electronics required to save the energy, okay, of electrical system. So that means power electronics saves the energy while operating. Okay, this is the main objective of the power electronics. So that is a, it saves the energy. Okay, saves energy while operating great flexibility. Okay, in electrical equipment here. So next one, the how do we obtain? This is the how do we obtain the saving energy and also great flexibility. So this can be obtained by using semiconductor devices as switches. Okay, so switches to turn on the power and also to turn off the power in desired direction at desired time. Okay, all of you getting my point? సో పవర్ ఎలక్ట్రానిక్స్ అనేది నువ్వు ఎనర్జీని సేవ్ చేయడానికి, ఎలక్ట్రికల్ ఎనర్జీ సేవ్ చేయడానికి మనకు కంపల్సరీ అవసరం. సో ఈ ఎనర్జీ సేవింగ్ మనం ఫ్లెక్సిబిలిటీ, వాట్ ఈస్ ద ఫ్లెక్సిబిలిటీ టు సేవ్ ద ఎనర్జీ? సో వన్ ఈస్ యూ కెన్ సేవ్ ద ఎనర్జీ ఇన్ ద డిజైర్డ్ డైరెక్షన్ అండ్ యూ కెన్ ఆపరేట్ ద స్విచెస్ in the desired direction and also at the desired time. So that is a all power semiconductor device are used as a switches, that is a bistable switches, that is on state and off state. So to turn on the power and power off, so at desired direction and at desired time. Got it point? So let us take one example. Okay, for this case, how do we save the energy? Okay, here in this question, so in this statement we have a question like, so that is a, how do we save, okay, this energy the by using power electronic devices? Okay, like this we have a question. So got it point? How do we save the energy by using the power electronic device? So to explain, okay, this part or to that to, so to know this saving of energy, let us take one example, that is a, so that is the speed control of, okay, here speed control of the DC motors here. Got it? So let us take one the example, how do we control the speed of the DC motor by using power electronic devices? Okay, exactly how do we control the speed of the DC motor by using the chopper circuit? Okay, this type of question. And let's see here, first one, here this is a, the DC motor is excited with the DC supply and it is a field winding and field system, and this one is a armature system or armature circuit here. So this armature circuit is excited with the AC, the DC supply here. So what about the rating of these motors? Okay, let us assume initially, so let assume the DC motor that is operated at a voltage of, that is a V rated is equal to the 200 volts. Okay, got it? And next one, I rated is equal to, at the I rated, so that is equal to 20 amps of the current. And the speed at this point, okay, here the N rated, so DC motor is operating under steady state condition at rated voltage and rated speed of the 1000 rpm here. Okay, this is a, all are initial conditions. Okay, these are the initial conditions. Okay, so we know here we have to operate. Now question is, how do we operate this the motor at a speed of the 500 rpm? So now let us find if Ra is equal to, okay, 1 ohm. So what about the back EMF? EB1 is equal to, so that is the EB1. So V minus Ia, the Ra values here. So now this is equal to 200 minus, so this is the 20 into 1. So it is equal to the 180 volts. So now question is, how do we operate? Okay, this is a, how do we operate this DC motor? Okay, operate the motor at 500 rpm here. So how do we operate this motor at 500 rpm? So by reducing the back EMF. Why? Because we know here, so back EMF is equal to, this is the back EMF. So EB is equal to 5Zn by 60, the divided by P by A here. So during operation of the motor, this way, the during operation, so this back EMF EB, the directly proportional to the N, and multiplied by flux here. So therefore N is directly proportional to the EB and inversely proportional to the flux. So it is a separately excited, so that this one is the flux is constant here. So from with this equation, N is a directly proportional to the back EMF of the motor. So to reduce the speed, to operate the speed at 500 rpm, so what we have to do here, so this back EMF of the motor should be reduced by 50% here. So now if that means here back EMF is equal to 180 volts. So if this one, if here EB is reduced by, EB is reduced by the 50%, then the motor will be operated. Will be operated. So at what speed here the motor will be operated? At a speed of the 500 rpm here. But question is, how do we achieve? This one is, so how do we achieve this part? This one here. Clear point? So are you getting my question? So here, how do we save the energy by using power electronic device? So here example point I have taken the speed control of the DC motors here. So let us assume here rated voltage is at 200 volts, rated current is at 20 amps, the speed is equal to 1000 rpm. Initially here if RA is equal to 1 ohms, back EMF of the motor is equal to 180 volts. So how do we operate the motor at 500 rpm? So if the back EMF is reduced by the 50%, then motor will be rotated at a speed of the 500 rpm. But how do we obtain? So this can be obtained by inserting the resistance in series with the armature circuit. This is some value of the external resistance. So now here this external resistance gives some amount of the power losses in the machine. So now here, so by inserting by inserting external resistance in series with the armature circuit, then we can get the speed is a 500 rpm. So but due to this what will happen, so as this one is as the resistance increases, external resistance increases, so what will happen here, so as external resistance increases, armature, the complete copper losses, so that is the Ia square Ra plus Re value, armature copper losses will be increased. So increased in the armature copper losses, the decreases the efficiency of the machine. So that this method is not desirable. So but instead of the external resistance, see, so now your question is, how do we get the speed? Here, how do we get the speed 500 rpm? 500 rpm. So without inserting external resistance, without the inserting external resistance. So how do we obtain this one external resistance here? So suppose instead of the resistance, so if I place the switch, here, the switch here, any semiconductor switch, so then we can operate this one. So this switch is we can operate with the power electronic device. So then what will happen? So here losses of the machine, losses of the motor will be decreased. So decreased in the losses, the increases the efficiency. Okay, efficiency here. So that what we conclude, by using the external, by inserting the external resistance in series with the armature circuit of the motor, the copper losses will be increased. Losses is nothing but the wastage of the power or wastage of the energy here. So this can be, the same results can be obtained by inserting one power electronic device between the source, okay, here, the between the source and the load, okay, so that, so what we conclude here, so power electronics saves the energy while operating great flexibility in the electrical equipment operation. Great flexibility means we can on or we can off at desired time and desired direction. So that is the meaning of the great flexibility. Okay, got it? All of you? Okay, is that clear, everyone? Why power electronics? Power electronics is required to save the energy. Okay. Next, one more question, that is, what is power electronics? What is power electronics? Okay, power electronic is a, okay, this one is power electronics, the is, okay, is technology, is a technology, so which deals about the power apparatus with the principles of electronics to control and conversion of the electrical power from source to the load by using semiconductor devices as a switches. So now we have a question here, what are the power apparatus? Okay, are you getting my question? Power electronic is a technology which deals about the power apparatus. What are the power apparatus? Like rectifiers, the choppers, cycloconverters, AC voltage control. All are the power apparatus. What are the principles of the electronics? That is forward bias, reverse bias, and these are called the principles of electronics here. And to control the control and conversion of the electrical power. So for example point, here we have taken, see, the first one, suppose here rectifier is there. First one of the power, the rectifiers. So what is the function of the rectifier here? So it converts the fixed DC to, okay, fixed DC to the here, sorry, the rectifier fixed AC to the variable, okay, variable DC. Okay, this is the rectifier part. And what it means, okay, it converts the electrical power conversion, so from source to the load, so that is control and conversion. So this output voltage can be controlled by using the firing angle of the SCR here. Now similarly, so this one is a inverter part is there. So in case of the inverter, it converts the fixed DC to, okay, here fixed DC, the two variable, okay, AC, so AC voltage and AC current, so which converts the control the output voltage, okay, and also the conversion from fixed DC to variable AC. And suppose if you take the cycloconverter, so this one is, okay, it converts the AC to the AC with different frequencies here. So how do we define the power electronics? Power electronic is a technology which deals about the power apparatus. What are the power apparatus? The rectifiers, inverter, choppers, and all are power electronic apparatus. And with the principles of electronic, and what is the purpose? To control and conversion of the electrical power. What from what point here? From source to the load. So how do we operate? So that is all by using operating as a switches. Okay, got it fine? Power in place of the resistor using power electronic device, then how we can back the EMF is reduced. That I will tell you in case of the chopper circuit. So very clear. So, but that is a we can operate some at some point, then operate switch as a off. So then what will happen? The average voltage of the switch can be reduced so that back EMF will be reduced. That part I will tell you. Okay, all of it clear? What is the power electronics and why power electronics? Okay, the power electronics is required to save the electrical energy. Okay, second one, why what is power electronic? It is a required, it is a technology or subject which deals about the power operators with the principles of the electronics and to control conversion of electrical power from source to the load by using semiconductor devices as a switch. So are clear point? So these are all the switches, all semiconductor device like power diode, power SCR, and the power BJT, power MOSFET, power IGBT. All are operated as a switches. That is the bistable switches on and off, so that you can control the power from source to the load. Control and also conversion. Okay. Okay, got it? Okay, this part is a very important. What are the advantages of the power electronics? Okay, anybody? Joseph, it's not links with the digital electronics. Okay, to learn here is a only the some part. We need a electrical circuit. Some basic subjects are required to learn the power electronics. One is the electrical circuit, and second one basics of the electronic circuits. Okay, and third one so some motors, electrical motors. Fourth one is the Fourier analysis, and fifth one is Laplace transformer. So the Laplace transforms. This one is a basic knowledge required to learn power electronics. Okay. Now tell me what are the advantages of power electronics? Anybody? Less power consumption. Very good. Next, high efficiency in power conversion. That's correct. Okay. So main advantages of the power electronics. Listen, all of you listen here. So that is a power loss. The power losses of any power semiconductor device. Power losses are less in the power electronics circuit. So now we have a question here. What type of power losses? Okay, in any power cell. So that is a power average power losses. Okay, that is a power the losses is equal to. Okay, got it fine? So this one is a power losses are equal to. So that is a one losses is the conduction power losses. Sometimes we have a question like conduction power losses of the power electronic device or power electronic circuit here. And this conduction power loss plus the blocking power loss. One more is a the blocking power loss, and in addition to this, so third one is the switching power losses. Okay, so these are the power losses of the power electronic circuit. So now we have a question. So what about the conduction power loss? Okay, and what about the blocking power loss? And what about the switching power losses here? Got it fine? So power losses is nothing but so it is a total power loss. Okay, this is the total power loss of any semiconductor device. Okay, semiconductor the device. Okay, that is the conduction power loss, blocking power loss, and also switching power losses. Okay. And what about the conduction power loss? This conduction power losses is nothing but so wastage of the power during on state of the device. Got it? Fine. Conduction power loss means so that is a wastage of power the during on state of the device. Okay, this is the on the state of device. Okay, got it point? On state of the device is here. So for example, diode is operating. So during the on state, so how much amount of the power wasted? So that is known as a conduction power losses here. Got it? Exactly on state. So during wastage of the power during on state of the device. Okay. And what about the blocking power losses here? So this is nothing but it is the wastage of power. Okay, wastage of power so during okay off state of the device. Okay, it is off the state of the device is called as a blocking power loss. Very important to solve the problems. Okay, power losses are less, everybody knows. What are the total power loss of any semiconductor device? So one is conduction power loss, blocking power loss. Third one is a switching power loss. So what about the conduction power loss? Okay, suppose you device operate చేయడానికి some amount of power అనేది వేస్ట్ అవుతుంది. ఆ పవర్ లాస్ ని మనం కండక్షన్ పవర్ లాస్ అంటాం. ఒకవేళ డివైస్ ఆఫ్ సపోజ్ డ్యూరింగ్ ద ఆఫ్ స్టేట్ some amount of the power is wasted, so that is the blocking power losses here. And next one, the switching power losses. Okay, switching power. So what is the mean by switching power loss? So suppose power wasted, okay, power or energy is required, so that is power wasted or energy required, power wasted. Okay, this is a wastage, power wastage of so to turn off. Okay, this is the to turn off and okay, this is the turn off and the to turn on. Okay, this is a the here, so that is a wastage of power, wastage power wastage to turn off and turn on, so that power losses is known as a switching power loss. So that is the four losses are there during the on state, during off state, and also to on state to the off state. Some amount of energy is wasted. That energy loss is known as the switching power losses. Now similarly to turn off, okay, to on state to the off state. So that power losses is known as a switching power losses here. Got it, point? So first point. So this is a power losses are less in the power electronic circuit, but total power loss, okay, conduction, blocking and switching power losses. Okay, now your question is how do we calculate these power losses? So cutting by mind, this one is a the question part, the numerical point of view. Question is a how do we calculate power losses of the device? Power losses. Okay, got it, fine. So this question is a very important. So this is the definition point of view: wastage of power during the on state, wastage of the power during off state, the wastage of power to turn off and to turn on the device. Okay, got it. So now question: how do we calculate the power loss? How do we calculate power losses here? See here, this part is a very important for. Okay, let us assume let so P of t, okay, P of t is a so is equal to so it is a V of t and I of t here. Okay, what is the P of t here? P of t is a instantaneous power. Okay, instantaneous the power of the device. Okay, like so instantaneous power means it depends on the okay instantaneous power in the sense so depends on the time varying nature. Okay, depends on time varying. So that power is known as the instantaneous power here. So now after getting instantaneous power, so this V of t is equal to V of t multiplied by I of t values. So how do we get energy here? So we know another term in the electronics, power electronics circuit, or energy loss or energy. So that is actual definition is the capacity to do the work, that is called as the energy here. But in this the equation point of view, energy nothing but, so it is a integral of, okay, it is the integral of, okay, instantaneous power, okay, instantaneous power here. So therefore this, how do we define this? Energy is equal to the integration, okay, from, so 0 to, from, for example let us take, so t1 to, okay, t2, so p of tn, okay, integration of the instantaneous power is known as a energy here. So where T1 is a initial value. Okay, this is nothing but the initial value of the some period. For example, so we have to find out energy loss during the off state. So that means initial value of the off state, and T2 is a final value of the off state here. Got it? So initial value and final value. So after getting energy, what about average power? Okay, this is a average power. So how do we calculate this average power? So this is represent, it is a P average power is equal to. So how do we define this average power here? So that is a average of, okay, instantaneous power, okay, instantaneous power over periods, okay, over what, over the one period, so is known as the instantaneous power here. How do we define this? So that is equal to P is equal to E by energy by time period T here. So therefore it is equal to 1 by T, the integral from T1 to T2 P of T, the dt here. These two formulas are very important for all calculations here, all calculations of power semiconductor devices. So got it point? So how do we calculate the power losses here? Always, so by using these two formulas you can calculate the power losses. Got it? Okay, we'll see here. First one, what are the advantages of power losses here? Losses are very less in the power electronic circuit. So next one, how do we calculate these power losses? So power losses can be calculated by using the instantaneous power equation. Instantaneous power means the power here, V of t means voltage, a voltage at time t. I of t here, current at time t here. So now energy is the integral of the instantaneous power. So that is called the energy. And average power. So that is the average of the instantaneous power over one period of, that is equal to average power losses. Okay. All of it clear now? So now here is a same question. When power is a less, then what will happen? The here efficiency of the machine. Okay, here efficiency of the less. Okay, in this case of the, sorry, power is a more, then efficiency of, okay, efficiency is more in power electronic devices as compared to the other electrical equipment. Okay, got it? One is power losses are less and efficiency is a more. And how do we calculate power losses? By using these three formulas. So first one, the here instantaneous power, and second one energy, and sometime another one is average power losses here. Suppose energy loss, question about the energy loss, use this formula. And question about average power losses, and this one is the, use this formula here. Okay, got it? So these three formulas are very useful in the first chapter. Okay, everything fine? Any more doubts? Okay, is that clear, everyone? Nageshwar, Pavan, sir, in circuit breaker used power electronics. There are many applications of the power electronic. So power electronics used in the electrical machine to control the speed of the electrical motors, and also power electronics used in the power system. So to compensate the reactive power, okay, at the load centers, and also voltage controllers, okay, and also protection system. All the for every application also, mostly in the electrical side, we are using the power electronic only, right? For saving of the energy, right? Very good. Okay. So next, one more question. So what are the disadvantages of power electronics? Anybody? Any disadvantage of the power electronics? What are the disadvantages of power electronics? ఏం డిసడ్వాంటేజెస్ ఉంటాయి పవర్ ఎలక్ట్రానిక్స్ లో? హార్మోనిక్స్, వెరీ గుడ్ పవర్. ఓకే, okay, here disadvantages of power electronics is a harmonic induced EM or harmonic voltage. Okay, voltages or currents here. So what are the reasons? Okay, that is a any power electronic. Okay, in any power electronic circuit, any power electronic circuit. Okay, power semiconductor device, okay, any device power semiconductor, the device used as a switches, the device used as the switches here. So that is the alarm. The switches means on state and off state. So for any switching, okay, whenever it is operated as a switches means, so therefore in the due to this switching action, okay, due to the switching action, the switching action of the device, okay, that it point due to that switching action of the device, all the waveforms, okay, all the waveforms, okay, will become non-sinusoidal. Okay, this is the sinusoidal, the periodic functions, non-sinusoidal periodic functions here. So this non-sinusoidal periodic functions is known as a, that is harmonic voltages and harmonic currents here. So any non-sinusoidal periodic function can be expressed in the series of the, so here is any the non-sinusoidal periodic function, non-sinusoidal periodic function can be expressed as, can be expressed expressed as the series of, okay, series of the sine functions, okay, sinusoidal functions. So by using sinusoidal functions, so by using the which one, so that is the Fourier series, okay, Fourier series, okay, this is a Fourier series. So that is equal to f of t is equal to, so a naught plus sigma n is equal to 1 to infinity, the an cos n omega t plus is a Bn sin the n omega Tn. So where n is a, okay, this part n is there. So n is equal to is a fundamental voltage exactly. So it is a pure sinusoidal, okay, pure sine function, okay, pure sine function here. And n greater than the here, greater than the one, it is a harmonic voltages, okay, harmonic. So this is called the disadvantages of the power electronics. So got it fine. So disadvantages of power electronics means like any power electronic switch, the power semiconductor device used as the switches. So due to the switching action of the device, all the waveforms will become non-sinusoidal periodic function. How do we represent this non-sinusoidal periodic function? Any non-sinusoidal periodic function can be expressed as a series of the sine functions by using the Fourier series analysis. So that's why we need some knowledge to analysis of the power electronic. So that knowledge is a Fourier series here. So that is any non-sinusoidal periodic function can be expressed with by using the Fourier series analysis. That is a naught plus sigma n is equal to infinity an cos n omega t plus bn sin n omega tn. Where n is 1 equal to, it is a pure sinusoidal voltage. N greater than the 1 is the harmonic voltages waveform. So this complete discussion about the harmonic part. So I will discuss about in this complete discussion in the chapter 2 here. Why? Because in the chapter 1, no need of any harmonics. So we have to know about the power semiconductor device. Then we will discuss about harmonic part whenever we start, before the starting of the chapter 2. That is a phase control rectifier or the DC to DC converters here. Okay, in the chapter 1, there is no the concept of the harmony, but in case of the chapter 2, so there is a harmonic concept is there. So that's why before starting that chapter 2, we'll discuss about clearly about the harmonic concept. Okay, got it all of you? Yes, n is equal to 0 means that is a so DC component, a naught is a DC component. Any doubts? So this is about the introduction of the power electronics. Why power electronics? What is power electronics? And also advantages of power electronics and disadvantages of power electronics. So all of you clear my point? Why power electronics? So that is power electronics is required to save the electrical energy. Okay, that can be achieved by operating the devices as a switches. Got it? And what is the mean by power electronics? Power electronic is a technology. So here technology which deals about power operators with the principles of the electronics. Okay. So this can be the to control and conversion of electrical power from source to the load by using power semiconductor devices. So that is about the what is mean by power electronics. And what are the advantages here? Power losses are less, and as the power losses are less, efficiency of the machine will be increases here. How do we calculate power loss? Okay, this part is a very important. So in the first chapter, so that is a the what is the mean by instantaneous power, energy loss, average power losses here. So instantaneous power means it depends on the time varying nature, and energy means it is the integral of the instantaneous power. So here T1 and T2 is a, so this one is a where the initial value and final value. So now where T is a time period. Okay, this one is the time, the period of the signal here. So average power. So average of the instantaneous power. So over one period, that is called as a average power. So these three formulas are required to calculate the some questions in the chapter 1. Okay. Got it all of you? Everyone. Why power electronics? What is power electronics? And also advantage and disadvantages of power electronics. Advantages of power losses are less, and disadvantage of harmonic effect. Harmonic voltages are developed due to the switching action of the device. Okay, got it? So next, see, in case of the chapter 1, Okay, let's discuss that. Chapter 1 is a power semiconductor device. So what are the power semiconductor device? One is a the power diode. Okay, first one. So this is the power diode, power diode. And second one is the SCR, okay, silicon control rectifier, or it's also called the thyristors here. And third one is a, so that is a GTO, gate turn off thyristor. And fourth one is a triac, okay, this is the triac. So this we'll discuss every clear all the power devices here. And fourth one is a power BJT, okay, all are power the bipolar junction transistor. Now similarly another one power MOSFET. Okay, so these all are transistors, power MOSFET. And one more, it is a the power IGBT here. So it is a combination of the BZ and the MOSFET here. So all are okay in entire power electronics circuit. These all are the used as a switches, okay, used as the switch, okay, here switch here bistable switch. So used as, okay, it is a used as bistable switch. Okay, so what is the mean by? So that means the switch here complete devices the used as a switch, that is the only for to turn on turn off the power. So by at desired time and desired level we can control the output voltage, okay, and we can transfer the power from source to the load, and also we can control the output voltages here. So actually we have a question, what is the difference between the signal diode and power diode here? The signal diode means the diode which is used in the analog electronics, that is called as a signal diode. And power diode is a, so some constructional changes there between the signal diode and power diode. That part we will discuss very clear in the constructional details. So what are the semiconductor devices here? Power semiconductor device, power S diode, SCR, GTO, triac, power BJT, power MOSFET, and seventh one is a power IGBT here. Got it? So now here all are, okay, this all the device, okay, all, so all power semiconductor, all, okay, this is a power, the semiconductor, the device is used as a bistable switch here. Suppose switch is a like this, okay, here it is a on state, okay, on state here, on state of the switch. Suppose switch is like that, suppose the signal is given like upward direction, so this is the off state of the switch, okay, got it fine. So this is the about the all our devices used as a switch. But in the analog electronics, the in addition to the switching there is a some other action that is called a amplification. So signal electronics are used for that is the turn on and turn off, as well as that is the amplification purpose. But here there is no amplification, only to turn on and turn off the power, turn off the input power, and at a desired level to transfer and to control the output voltage. Okay, got it? Are you clear about this one? So now we have a question. All are used as a. Are getting my question? All the devices used as a bistable switch. So that we have to know about what are the characteristics of the switch. Okay. And what are the characteristics of the ideal switch? And what are the characteristics of the practical switch? Okay. This type of question. Are you getting mine? So now let us discuss that part. Okay. So before knowing about exactly ideal part, the practical question. So now let us discuss what are the characteristics. Okay, here. What are characteristics of ideal switch? Okay, ideal switch is not possible. So that is the imaginary switch. Okay, like. So next one. What are the characteristics of the practical switches. Okay, practical the switch. Okay, that means so any semiconductor device like so diode, SCR, GTO, triac, BJT, MOSFET and IGBT. Okay, all are so used as a switches. So what are the characteristics of ideal switch and what are the characteristics of practical switch? Okay, got it all of you? This is the discussion about the power semiconductor device in the chapter 1. Okay. Now let us discuss about the ideal switch and its characteristics. Ideal switch and its characteristics. Okay, Sham Sundar, good evening, sir. Sorry, power cut time so late time. Okay, no problem, Sham Sundar. Sometimes happens like that only. Okay, ideal switch and its characteristics. Okay, listen. So what is mean by ideal switch? Okay, first we will discuss about what is the definition of the ideal switch here. So ideal switch is a bistable switch. Okay, here which cannot be realized in practical cases. Okay, don't think about there is no ideal switch here. So here is a simply ideal switch is a it is okay it is bistable switch. Bistable means so two states are there. Bistable switch. So which cannot be realized, which cannot be realized, can't be realized in practical case. Practical case. Got it point? So here the similar the this is the only imaginary purpose. Okay, it cannot be realized in the practical case. But if we know all the characteristics, you can compare the practical switch with ideal switches here. Okay, got it? So first characteristics. Okay, this one is a so what are the characteristics of the practical switch here? Sorry, ideal switch. So first characteristics is a so first characteristics is during the on state. So during on state means suppose if you take see this diagram. So this one is a we have taken that these diagrams. Okay, see here all of you. Okay, this part. So during the on state, that means positive of the switch. Okay, here switches means any device, any power electronic device here. So anode is connected to the positive and cathode is connected to the negative. So this is nothing but here. So here forward bias, so that switch will become closed. So this is called as a exactly example for. So this the example is a closed switch. Okay, here so this one is a example for the closed switch here. So in case of the closed switch, then what will happen? See, okay, in case of the closed switch, what will happen? So here in case of the closed switch, what will happen? So when the this is the Vs is the voltage. Okay, this point voltage across the switch, not the supply voltage. And this the ISW is a current passes through the switch. So that you can write here, let VSW is a voltage, the voltage across the switch here. Okay, and ISW is a current passes through the switch. Okay, this is the current passes through switch. So therefore, see when switch is on, okay, during the on state, okay, here. So during on state here, so then what will happen? So current here, total current. So there is no resistance here. So that is there is no internal resistance. Therefore, the current is equal to the IS switch. Switch allows the infinity amount of the current. Okay. So with voltage drop is a so voltage across the switch is nothing but drop. So that is the voltage VSW is equal to 0 here. So therefore what we conclude here, so during on state of the ideal switch, okay, during on state of ideal switch here, so what will happen, so that means it allows the infinity amount of the current. So that means it carries the unstate of the ideal switch, the here it allows infinity amount of the current, infinity amount of current with zero voltage drop, with zero voltage drop across it here. This is the first characteristics. So all of you got in point. So during the on state of the ideal switch, it allows infinity amount of the current with zero voltage drop across it. So therefore here current passes to the switch is infinity. Voltage across the switch, voltage drop across the switch is equal to 0. Okay. Very good, Nageshwar. VSW is equal to 0. ISW is the infinity. Okay, very good. Okay, is that clear, everyone? Tell me, is it okay or not? Okay, next second condition. See, the second one, during off state of the switch, then what will happen? Okay, see. So what will happen? The second characteristics of ideal switch. So here anode is connected to the negative terminals. Okay, and this one is the cathode terminal is connected to the positive terminal. This is the switch. So now what will happen? It is a reverse bias so that it will become open. So now example point, this is the exactly the open circuit. Okay, open circuit here. So when open circuit means it offers how much amount of impedance here? Infinity amount of the infinity. So when infinity is the here infinity value, what will happen? Current passes to the switch. So therefore here current passes through the switch is equal to 0. When the current is equal to 0, voltage drop here. So therefore VSW is equal to, so it is a infinity. So this is a complete the infinity amount of the voltage drop. So what we conclude here, so this is a the during on state. Example for this case. So exactly it is the switch and it is a during off state of the switch. Okay, third example. So this is the during off state of ideal switch, what will happen, so that is a it blocks the infinity amount of the voltage. So it block, that means, so just apply the voltage across, suppose, so it blocks the infinity amount of the voltage with zero leakage current. Okay, that means it blocks, okay, blocking, okay, it blocks infinity amount of the voltage, infinity amount of voltage with zero leakage current. Okay, with zero value of zero value of the leakage current. Leakage current. Okay. So clear point. The second condition, second characteristics here, during off state of the ideal switch, it blocks the infinity amount of the voltage with zero value of the leakage current. Okay. VSW is the infinity and ISW is equal to, no. Actually, just apply a source here. For example, in this case, V is equal to here, this Vs is equal to the infinity values is there. So therefore, just apply the KVL in this loop. Okay, here. So it is a minus and it is a plus. Okay, this part. So just apply here. How much amount of voltage? Okay, it blocks the infinity amount of the voltage. So that is equal to, so here is a Vs, that is the voltage across the switch is equal to Vs only. So now this is equal to, that is how much? Okay, yeah, up to infinity voltage. It blocks the infinity amount of the voltage during the off state. Pawan, is it correct? Right, current is equal to 0 and voltage. Next, third one, third characteristics. See here, all of you, third one. What is the third characteristics? Anybody guess? Characteristics of third characteristics. Okay, third characteristics is, okay, listen all of you. Here, in case of the ideal switch, okay, here time taken by the ideal switch to turn on is equal to 0, and time taken to turn off the switch is also equal to 0 here. That means here ideal switch can change its states, so instantaneous at the very sharp level. So that means time taken to turn on the switch. Okay, that is a, so this is a turn on time, that taken by, time taken to turn on the switch. Turn on the switch, and that is equal to, okay, this, the time taken to turn on the switch is equal to 0. Okay, it is equal to 0. Similarly, time taken to turn off the switch, okay, turn off switch, so that also is equal to 0 here. So it is nothing but t on, turn on time, and also this is a, the turn off time. Okay, here. So when t on and t off is equal to 0, so what about the total time? So this is the total time is equal to t on plus the t off. Okay, t off here. So now this is equal to 0 here. When total time period is equal to 0, what about the switching frequency here? The switching frequency, so that is equal to how much? 1 by t. Okay, 1 by t is equal to, so now it is a 1 by 0, so it is equal to infinity 1. So that means the switching, the time taken to turn on and turn off is equal to 0 in case of the ideal switch. And what about the switching frequency? The switching frequency ideally infinity, but practically any switch cannot has infinity value of the switching frequency. Okay, it takes some time to turn on and turn off. That's why switching frequency is not equal to infinity in case of the practical switch. Okay, very good. And next, fourth characteristics, okay, of the ideal switch, fourth one. Fourth characteristics. Okay, is there any power required to turn on the switch here? Okay, here. the energy, no energy is required to turn on the switch. So the no energy is required to turn off the switch. So therefore, power loss, okay, here, power loss of the ideal switch, power loss of ideal switch is equal to, so that is equal to 0 here. So what about this power loss? Complete power losses. So that is the blocking power losses. Okay, that is the conduction power loss. Conduction power loss. Okay, that equal to 0. And also, so next one, the blocking power loss is also equal to 0. So blocking power loss. So there is no blocking power losses in case of the ideal switch. And also switching power losses. There is no switching power, no wastage of energy to turn on the switch. So that's why switching power losses also equal to 0. So these are the four characteristics of ideal switch. Okay, are you clear point? So I'm explaining very clear, and that is a, no need to write notes, just read, okay, and listen the class very careful. So you will get everything. No need to fear about the power electronics. Power electronics difficult కాదు. సో నేను సింపుల్ గా ఓకే మీకు ఈజీ వేలో ఎక్స్ప్లెయిన్ చేస్తాను. మీరు క్లాస్ కు అటెండ్ కాండి, ఈ వీడియోస్ షేర్ చేయండి, లైక్ చేయండి. మీకు ఎంత ఈజీగా అంటే అంత ఈజీగా నేను పవర్ ఎలక్ట్రానిక్స్ మీకు చెప్తాను. బుక్స్ లో చాలా డిఫికల్ట్ మెథడాలజీ ఉంటుంది ప్రాబ్లమ్ సాల్వ్ చేయడానికి. నేను అలా కాకుండా సింపుల్ వేలో ఒక మీకు ప్రాబ్లమ్స్ ఎలా సాల్వ్ చేయాలా, అనాలిసిస్ ఎలా ఉంటుంది. ఐ ఆల్రెడీ మెన్షన్ ఇన్ ద మిషన్స్ ఆల్సో. వీ హ్యావ్ టు డిస్కస్ అబౌట్ కంప్లీట్ థియరీ, అనాలిసిస్ అండ్ ఆల్సో ప్రాబ్లమ్ సాల్వింగ్ టెక్నిక్స్. ఈ 3 పాయింట్స్ మనం డిస్కస్ చేద్దాం. ఎవ్రీ కాన్సెప్ట్ లో కూడా కంప్లీట్ డీటెయిల్ డిస్కషన్ ఆఫ్ ద థీమ్. అండ్ నెక్స్ట్ వన్ అనాలిసిస్, క్వశ్చన్స్ ఎలా అడుగుతారు. సో నెక్స్ట్ వన్ ప్రాబ్లమ్స్ ఎలా ఉంటాయి, ఒక ప్రాబ్లమ్ సాల్వ్ చేయడానికి ఎలాంటి టెక్నిక్స్ ఉంటాయి. సో ఆ పాయింట్స్ మనం డిస్కస్ చేద్దాం. ఓకే, రైట్. Yes, no switching losses, no conduction loss, no blocking power losses, and everything all are equal to 0 in case of the ideal switch. Okay, clear point? So during the turn on, okay, here it allows the infinity amount of the current with 0 voltage drop across it. So next, during the turn off, it blocks the infinity amount of the voltage with 0 value of the leakage current. So that means exactly it is act as a open circuit or open switch. Okay, and next one, time taken to turn on the switch is equal to 0. That is the on time is equal to 0. Time taken to turn off the switch is also equal to 0. When time is equal to 0, what about the switching frequency? Infinity. So ideally the switching frequency of the any device is a infinity, but practically we cannot get infinity value of the switching frequency. Joseph, okay, till end of the December it will be complete. How many days required to complete the subject, sir? Till end of the December. So for GATE 2021, you can, by reading these notes and class, by listening the class, you can attempt the GATE 2021. Okay, all of it clear? So see here, let us take one example here. Example for ideal switch. Okay, this is the example. Okay, here for ideal switch. Ideal switch. Ideal switch on state and off state. Okay, how do we on state and off state here? So this is we have taken one example for ideal switch on state and off state. So let us assume initially, okay, this is the on state of the switch. Okay, on state. Okay, initially on state value, and after that it is a off state of the switch. Okay, from here to here. So that means it is a 0. Okay, 0 here, and this one is a t1. Okay, like, so time t1, and this is the T2 time, and this is the, so this is on state and it is off state. Okay, and again it is a on state. Okay, like this we are operating. So now when it is on, when the ideal switch is on, okay, let us take. So what about the voltage or what about the current here? So let us assume this is the current passes through the switch. Okay, current one. So next one, this is a the current voltage across the switch. Okay, voltage across the switch. And what about this part? Okay, this one is a the power loss. Okay, here power loss. Okay, PSW means the power loss the due to the this switch. So now this voltage, how much amount of voltage can block or can withstand, how much amount of the voltage. So during the on state, so let us assume, okay, it is allows the high amount of the current. Okay, it allows, so this is a, so I amount of the current. Okay, got it, fine. So this one is a I amount of the current during the on state. Okay, and what about the voltage during the on state? Okay, this represent the, so this is the represent the voltage drop. How much amount of the voltage drop during on state? So that voltage drop is equal to the zero. Okay, this is the zero voltage drop. And here power loss is equal to, so we know that how much amount of power loss. So that power losses are equal to zero. Why? Because so there is a voltage is equal to zero, instantaneous power. The simply instantaneous power during the on state. So that is equal to zero. And similarly, during off state, so suddenly there is no time required to turn on state to the off state. So from year to year, okay, this is the on state. Okay, this one is the on state and it is the off state. So no time is required to turn on the switch. Okay, suddenly it turn off. So now it is a turn off. What about the current? So current passes the switch is equal to here the zero current. So what about this is a current passes through. Okay, like this a voltage. How much amount of voltage blocks here? So V amount of the voltage. Okay, V amount of voltage. So now this we called as the V amount of the voltage. Like this, the V amount of volt. So now next one, what about the power here? Power is equal to zero. So now at T2, we are again we are the open, we are on the switch. So now it is on the switch. That means the current here voltage comes to the zero, but power, here current will be increases to I amount of the current. So like this, okay, this is a period. So now this is the switching the period here. Okay, like this is the on state and off state values here. So calculating fine. So like this we are calculating. Okay, time period. So on state, on state and off state values. Okay. So therefore completely power. Okay, power losses is equal to zero. So now let us calculate. Okay, this is a, so conduction power losses. Okay, how do we calculate the conduction power loss? Okay, instantaneous conduction power. Okay, power loss. Okay, that is equal to, so P of T is equal to V of T I of T here, induction, instantaneous current. So now this value is equal to, here V of T is, there is a the zero and I, so therefore so that is equal to zero here. So instantaneous conduction power. So average power loss, that is equal to over the period of the time, but that is equal to zero. So simply blocking power loss is also equal to, okay, blocking the power loss. How much amount of blocking power loss? So that's also equal to zero. So is there any switching power loss? Is there any energy required to turn off the switch and turn on the switch? No energies are required to turn on the switch, and no energies are required to turn off the switch. So therefore here switching power losses. So this is the switching the power loss. Okay, that's also the equal to zero here. Okay, this is the exactly. So power loss is completely zero per ideal switch. Okay, ideal switch. All of you got it? Yes. Okay, is that clear, everyone? Okay. So next let us discuss about what are the characteristics of the practical switch. Okay. So first characteristics is a see. So this is the during the on state. Okay. For example, this is the example for the on state. Okay, on state of the switch. Okay, on state. And this one is a example for off state of the switch. Okay, here off state. We have taken the two stated here. So now first tell me the during the on state. So here A is a here anode is connected to the positive and this one is the cathode is connected to the negative. So that is the forward bias. The switch will become closed. Okay, here this is the example for the on state is a that is the closed switch. Okay, closed switch here. So when it is a closed switch, so what will happen? It allows some infinity amount of the current. The current passes through the switch is a high amount of the current, some high amount of the current. But voltage drop, okay, VSW, okay, that not equal to zero. Okay, not equal to zero. Okay, got it, fine? Okay, not equal to 0. But in case of the off state, the it is a voltage. Okay, here voltage. So this the it is a open switch. Example is a simply open switch only. So in this open switch, the what about the the current here? Current is not equal to 0. So but here the voltage across the switch. So it can block some the some finite value of the voltage here. So these are the two equations. So that first parameter you can write. So first characteristics here. Okay, characteristic. So now this is a the during the on state. Okay, during the on state. So what will happen? The practical switch. Okay, practical switch allows finite amount of the current. Okay, during on state. So that is a practical switch. Practical switch the allows finite amount of the current, finite amount of current with small voltage drop across it. Okay, small voltage drop across it here. Got it, point? So here during the on state, practical switch allows finite amount of the current with small voltage drop across it. Okay, got it? And second one is a so during the off state of the switch. Okay, these are during off state. So what will happen? So this practical switch. Okay, here see the off state example. So the practical switch it blocks the okay here this is a it blocks how much amount of the voltage. Okay, it blocks the finite amount of the voltage, finite voltage amount of the voltage. So with small leakage current, okay, which is a the small the leakage the current. This is the another characteristics of the practical switch. Got it, point? Okay, on switch on అయినప్పుడు నీకు ఎంత కరెంట్ అనేది ఐడియల్ కేసెస్ లో ఇన్ఫినిటీ కరెంట్ ఉంటుంది. అదే ప్రాక్టికల్ కేసెస్ లో ఇన్ఫినిటీ కరెంట్ పాసిబుల్ కాదు. ఓన్లీ సమ్ వాల్యూ ఆఫ్ ద కరెంట్ దట్ వీ కెన్ కాల్ యాజ్ ఏ so some finite value I amount of the current here. So next the during the up state it blocks the finite amount of the voltage with small leakage current passes through it. Okay here so passes through the it. Okay, it is a very important point. And next third one is a so that is a the switching frequency is not infinity. So that is a this the t on time turn on time and turn on time not equal to 0. Okay, and also turn off time also not equal to 0, not equal to 0. So therefore here the switching frequency is not equal to infinity values. Okay here. So it is always less than okay switching frequency is less than the infinity some finite value. Okay, so now this you can write the switching frequency also. Okay, here some finite value here. So next one, fourth characteristics. So here power losses. Okay, here complete the power loss are not equal to zero. Okay, so there are some power losses occur in the practical switch. Okay, got it, fine. That during the on state, it allows the finite amount of the current with small voltage drop. So during the off state, it blocks the finite amount of the voltage with small leakage current. And next one, turn on time not equal to zero and frequency is not equal to infinity here. Okay, frequencies the some finite value. Fs is also some finite value here. Okay, all of you clear about practical switch characteristics? No. Mechanical switch is a power. We are thinking about the mechanical switch. Mechanical switch is required, but in the electronic circuit, for example, in order to turn off the thyristor or in order to turn off the SCR, we need some energy. Okay, in order to turn on the SCR, we have to give some gate pulses. That is called as a energy here. So it takes some time to turn on. Okay, it takes some time to turn off. So like this, we have to give some energy to bring the device bring the device off. We need some energy to bring the device on. So that is called, when in ideal cases that no energy is required. In practical cases, so we require some energy, okay, to turn on and turn off. So that is wasted by the device which is used in the circuit. So that's why we can call it as a that is a power losses, okay, occur in the practical switch. Okay, got it, everyone? Okay, listen here, all of you. Okay, this is the, let us take one example point. The example of the for the practical switch of on state and off state. Okay, we have taken one example for the practical switch of on state and off state. Okay, got it? So now let us take one example. So this one is a, the current passes to the switch ISWN. Okay, current passes the switch. So now this is equal to current passes to the switch. So that is a IS of TN in the function of the time. That's why we have taken the current passes to the switch. And next one, this is equal to the voltage passes, that is equal to the V voltage across the switch. Okay, VSW of TN in the function of the time. Now similarly, power loss. Okay, so that is the average power losses, PSW1. So initially when the switch is on, so let us take it is on state, okay, from year to year. So it is a on state during the on state values here. So next one, let us assume here it is a T1 time, okay, it is a T2 time. Similarly, so this one is a T3 and it is a T4 like. So now it is a from year to year. So this is the off state of the switch. We are off. So this one is the off state of the switch. We are going to off the device. So next one, this period, and here it is a on state of the switch here. Okay, like on state, off state, and on state here. So when it is on, how much here during the on state. So it allows the finite amount of the current. Okay, finite amount of the current. So this current we can write I amount of the current. Okay, finite amount of current. So but in order to suppose if you want to turn off, it takes some time. It cannot direct, you cannot abruptly equal to zero. Sudden zero car. It takes some time to turn off. So that's why. So it takes the some time to turn off. But so during the on state, okay, yeah, during the on state, yeah. So what about the voltage? It has some small amount of the voltage drop. So when current is a decreases to the switch, so this voltage will be increases here. So like this. So when it is a up, how much amount of the voltage block? So suppose so this is a the V amount of the voltage. So during the up state here. So now it allows the very small amount of the current. Okay, small amount of the current here. Now similarly again if you want to turn on the switch, so it takes some time from T3 to the T4. Okay, this is the T3 to the T4, and the during the on state it's a I amount of the current. So now it is a off state. Again it is a we want to turn on the device, voltage is a decreases, and during the on state it has some voltage drop like this here. So this is the exactly waveforms of the current passes to the switch, and also voltage voltage across the switch. Okay, got it? So now what about the power? Power is not equal to zero. So it has some amount of the power losses. Okay, during, so this is a power loss. So during the on state of the switch. And similarly, these are the power losses during off state of the switch. Okay, like this. Okay, during the off state of the switch. So next one, this is a the during the off state of the switch like this. So how do we calculate this power loss? Okay, here. So this is a the switching power losses. Okay, completely. So these power losses are called the switching power losses. What about these losses here? So this is a okay this part okay here. Okay, this part is a, so it is a conduction power loss. Okay, conduction power losses, power loss, and this is a the blocking power loss, blocking power loss. Okay, from T1 to T2 is a so switching power loss. Okay, and this is also okay, these three are okay, two are, it is a switching power loss, power losses here. Got it, fine? So this is the conduction power loss, switching power loss, and also blocking power losses. Very good. So now question is how do we calculate? Okay, here. So these the switching power losses here. So now power loss or energy loss. So from energy loss, energy loss to turn off the device. So this period of the time, okay, this period is nothing but, so it is a T off, okay, T off here. So now this period is a T on, time taken to turn on. Time taken to turn on. Okay, got it? So now we have a question, how do we calculate the power losses or switching power losses here? So now one of the question in this diagram only, see the energy loss, okay, to turn off turn off the switch or device. Okay, energy loss to turn off the switch. How do we calculate energy loss to turn off the switch? Integral of, okay, integral from t1 to t2. Okay, t1, sorry, t1 to t2, p of t. Okay, p of t here. So this value is equal to, so that is the 0 to t of, okay, 0 to t of, okay, t1 to 0 to t of period. So that is the V of t, okay, V of t multiplied by I of t here. Voltage across the switch and the current across, current passes through the switch values here. So this is the energy loss to, energy loss by the device, okay, energy loss by the device or the switch. So to turn off, okay, got it point. So energy loss, how much amount of energy loss, the to turn off the switch or device, okay, practical device. So that's why how much, how do you calculate? So this is a t1 to t2, 0 to t of and v of t here. So now where v of t is a, okay, how do we calculate the equation? Okay, equation. So for v of t, okay, v of t equations here. So how do we calculate the equation of the v of t? Anybody? Okay, equation of v of t. Equation of v of t here. Got it? See this diagram. So here from year to year we are calculating the energy loss, how much amount of energy wasted to turn off the this device. So therefore here it is a, let us assume it is a 0 and total time is a t off. So in this case how much amount of energy loss or power loss, let us find initially. So how do we calculate? So this I of t equation and v of t equations here. So here this is the slope V of t equation. See, the slope is a increases. Okay, it is a straight line equation with increase, progressively increases here. So that you can write, okay, this part, okay, you can write. So we have taken one equations like, so now this is a progressively increases like, so now this is a the equation here, the x, okay, so this is the y axis, okay, this one is the x axis here. So in y axis in the here, this is the voltage v of t, okay, v of t, and I axis is a, so this is equal to I t here. So next one, it is equal to 0 of 0, and this part is a some I amount of the current, okay, I amount of the current, sorry, V amount of the voltage, and this is a, that is equal to, so at a time t of, okay, t of values here. So how do we calculate this equation? By using the straight line equation. So that is a y minus y1 is equal to, so there is a straight line equation. So now it is equal to y2 minus y1 divided by the x2 minus x1. So multiplied by x minus x1. Okay, it is a straight line. So what about this y1 end? So it is a 0, the 0, 1 coordinates and other coordinate here. So now this is equal to, it is a t of, okay, t of and v, okay, t of and v. So now it is a x1 y, the y1, and it is a x2, and this one is the y2 parameters here. So therefore simplify here. So y is equal to v of t, okay, v of t, y1 is equal to 0 and y2 is equal to v minus, okay, the 0, and here t minus 0, okay, t, the t of minus t, x2 is equal to t of, so t of, okay, the x minus, here x is the coordinates is the xt minus 0. So therefore v of t is equal to, okay, v of t, so that is equal to v by, so t of, okay, t values here. So this is the straight line equation with positive slope. Okay, this one is the straight line equation. So with positive slope. Got it point? Positive slope. straight line equation with positive slope. Now similarly, how do we get current equations here? Equation of the, okay, similar way, how do we get equation of the Vt, equation of I of t, okay, that from that this is a t1 to a t2, equation of I of t from the t1 to t2 values here. How do we answer this question? See this diagram, very important. It is a, this is the initial value, right, and this one is the final value here. So this is a, here decreases progressively, okay, decreases progressively here. So now let us draw, so this coordinates for this case. So if this one is a, okay, voltage current the line and x axis here. So I have taken, this is the y axis and x axis here, then y axis is a I of t, okay, and this one is a the t here. So it is the initial value and the final values here, okay, like this. So it is the initial value and final value. So this is the here initial values. So that is equal to 0 the comma I amount of the current, okay ji. And this one is how much period here, t of. So that is the t initial value is the t of, okay, t of and the 0, okay. This is a, the, it is also straight line but with negative, the negative slope. So why we, how do we write this equation? Y minus y1 is equal to y2 minus y1 divided by the x2 minus x1, the x of x minus x1 here. So now simplify this equation. Y is equal to I of t, okay, I of t. Y1 is equal to the I amount of the current. So y2 is equal to, okay, this is the y2 is the 0 minus I, x2 is equal to, so this value, the x2 value is the t of, okay, t of minus the 0, x1 is a 0. So x is equal to t minus, okay, this is the x1 equal to 0 values here. Now simplify this equation. So I of t is equal to, so I amount of the current, that is the 1 minus, so t by t of, okay, t of here. So this is the equation of the straight line, okay, equation of the straight line. So with negative slope, okay, negative slope of the line, okay, equation of the straight line with negative slope. Very good, nice one. Problems point of view, it is a very important. Okay, got it, all of you? Okay, now you can calculate P of t and V of t. So therefore, let us calculate energy loss during the turn off. Okay, this is a, therefore, so it is the P of t is equal to the V of t, the into I of t values here. So V of t is equal to, so that is a V by, so this one is a, the V by t of multiplied by t. So into, okay, I of t is equal to I into 1 minus, so t by t of, okay, t of. So therefore it is equal to, so calculate this value. So that is equal to vi, so vi, okay, divided by t of multiplied by t, okay, it is a t here, minus, okay, t square, okay, divided by t of, okay, t of values here, okay, t of, okay, this is a P of t. So therefore energy loss, okay, here energy loss to turn off, okay, this is the turn off. So how much amount of energy loss during the turn off? So that is equal to integral of P of t, okay, calculate. So how much here from 0 to t of time, okay, t of time here. So now this is equal to, simplify this equation from 0 to t of, okay, t of, so this value is equal to, okay, vi by t of, okay, vi by t of, so now it is equal to t minus the t square by the t of values, okay, t of, so dt here. So now simplify this equation, okay, v of by t of is a can, so it is a common, so vi by t of, okay, t of, so now it is equal to t square by, okay, simply you can write directly t of square, so by 2, okay, by 2, the place, okay, t of square, okay, t of square, t of cube, so divided by, okay, this the 3 into t of, okay, by simplification. So now this is the t of will be the cancelled out, it is the 2 square, so therefore it is equal to, so vi by, okay, vi by 6, okay, this is the energy loss to turn off the switch. Vi by t, dt is there, so that's why you can write energy loss to turn off the switch, t off. Okay, got it all of you? Very good, very good. So next, similar way, how do we find out energy loss to turn on? Energy loss to turn on the switch. Turn on the switch here. So you will get same. So that is equal to integral of the 0 to t on, okay, t on the v of t, p of t dtn. So therefore it is equal to 0 to t on, so v of t, okay, I of t. So calculate this value. The here same value will get 0 to here vi by the 6, okay, the t on. So therefore total energy loss is equal to total the energy loss, so that is equal to, so the energy loss to turn on and turn off, so that is equal to vi by 6, so plus t on, okay, plus t off, okay, yeah. So now what about the power loss? Okay, how do we calculate power loss? Okay, power loss, average power loss, the switching power losses, average, okay, it is the average, the switching power losses, switching power loss. How do we calculate average switching power losses here? Okay, energy loss divided by over period of the time. So therefore it is equal to, so vi by 6. So it is equal to frequency, switching frequency multiplied by energy loss. Like this we have to calculate. Any waveform is given. So if we know these two equations, okay, it is the equation of the straight lines. Okay, it is very, very important. Okay, completed? All of you? Yes, that is the energy loss of this diagram. Okay, can you solve this question? Tell me the answer for this question. So which was given gate 2005. Okay, the figure shows the voltage across a power semiconductor device. and the current through the device during the switching transition is a transition to turn on the transition or turn off the transition. What is the energy loss? Okay, it is the energy loss. What is the energy loss during the transition? Transition means state. Okay, from the on to the off and off to the on. That is the meaning of transition. Okay, calculate this question. What is the answer? First, tell me here. See in this diagram, all of you. Okay, I am dividing this diagram. Okay, like. Okay, suppose voltage is a I. Okay, volt, and current is a increases from T1. Okay, in this period of the T1, voltage and current. Okay, voltage is a increases. Sorry, voltage is a constant. V is a constant here. So that is a during the T1. Okay, during T1 period. T1 period. So what it means? Voltage is a constant and current is a increases here. So voltage is a current. So next one, in this period, after some time, okay, during the T2 period. So then what will happen? See, the T2 period. So now it is the I is a constant. Okay, I is a constant and voltage is the decreases. Okay, now. So at what condition? Suppose I is a constant, voltage is a increases. So that this is the device is in the on state. Okay, it is a so turn on state. Okay, turn on, the suitable for the turn on state. So this is the suitable for turn on state. Got it fine? So next one, how do we get okay this power losses? Okay, energy loss. So we have a formula here to calculate the energy loss. So energy loss is equal to energy loss. So that is a integral of the power loss. Okay, integral of the this instantaneous power. So now it is a integrals from okay see 0 to T1. This a total time is a T1. It is not instant. This is a total time T1. This is a total time T2. So therefore this equation you can write. So that is a 0 to T1. Okay, 0 to T1 total time in the period of the T1. So now P of T is equal to V of T. So the I of T. Okay, I of T values. The dt, the place. Okay, this is the one. And similarly, so that is the next one. So here from 0 to T2. Okay, this is in the period of the T2. So V of T, I of T. Okay, I of T dt here. So here V of T is equal to, okay, in this case, V of T is a constant, right? So therefore it is equal to V of T is a V. Okay, here some value of the V. So this equation you can write, see, this one is, so 0 to the T1. So V of T is a VDC, constant value V. So next one, I of T is a progressively increases, that is the equation I of T. So dt values, okay. So plus, okay, here. So that is the integration 0 to T. So current is a constant here. So that is the I amount of the current. So next one, V of T, okay, dt values here. So calculate this value. So V is a constant. So that's why it is a common. And next it is out of the integration 0 to T1 and it is equal to I of T, okay, dt. The place, okay, it is equal to the here I is the this one is a I, the out of the integration because it is a constant. So that 0 to T2, okay, T2 values. So that is the V of T, the dt values here. So now calculate, see. So this part, okay, this part is a so average of the current. So now it is equal to V into I average, okay, integration. The place, okay. So now I into, okay, V average, okay, V average here. So how do we calculate average value? So area of this one, okay, this area, okay, like, okay, in this area. So now this is equal to V I average is equal to half into, okay, half into, so that is a I, okay, IT1, okay, IT1, okay, IT1 plus, so I into, okay, it is a half, okay, it is a V into T2. So now calculate this value. So by simplification here, so we will get, it is a VI by 2, okay, T1 plus T2, okay, T1 plus T2. Okay, that is the on state, okay, turn on. So that is the on state, okay, V by 2 T1 plus T2. V by 2, okay, this is the V1, VI by 2 into T1 plus T2. That is the mean. Okay, is that clear everyone? So this final answer I have written here. Suppose if you want to find out this integration, directly we can write the average value means the area occupied by the current equation. Okay, so now it is a, suppose in this case I average, okay, I average means, okay, I average, so that is the area occupied by, okay, occupied by the current equation, okay, equation. This is equal to integration, okay, from this 0 to t1, okay, v of I of t, okay, I of t dt. So next one, so similar way, so this is a v average in the sense the area of the curve, area of the curve, the by the voltage equation. Okay, this one is area of the curve by the current equations. So now this is equal to, you can write integration of from 0 to t2, here v of t, okay, v of t. So that's why here no need to integrate this one. So only this area, okay, just it is a triangle. So that's why this area we can write 1 by 2 into, so I into either T1, okay. So next one, this area we can write 1 by 2. So area of the triangle, area of triangle, right? So now this is the 1 by 2 into, so it is a V the into the, that is equal to T2. So calculate this. So now you will get VI by 2. Total power is equal to, you can calculate like this. Okay, got it everyone? Okay, in the shortcut manner, suppose this area here, okay, this area. So suppose this is also one triangle. In this the same period, it is a triangle. So that's why we are calculating, okay, area occupied by the curve the of the voltage equation. Okay, Joseph, is it clear? Next one, calculate this problem answer for this question. Okay, it is the last question. Do it fast. Same concept. The voltage across and current through the semiconductor switch during the turn-on transition are shown in the figure. The energy dissipated, okay, energy dissipated during the turn-on. Okay, so during the turn-on. So in this period, Okay, from year we have to calculate from year to year. Okay, during the turn on transition in millijoules is dash. So this is the gate to the gate the 16th question. How do we solve this question? Simply here see the energy is equal to energy loss. Energy loss. So see here all of you. So integral of the power, instantaneous power P of t. Okay, it is equal dt here. So let us divide this into two parts. Okay, P of t here. So from t1 microseconds, t2 is a microseconds. Okay, so therefore, so that is a 0 to t1. Okay, t1 microseconds. So that is equal to P of t. Okay, P of t. So dt plus the 0 to t2 microseconds. Okay, P of t the dt. Okay, got it? So P of t dt. So now simplify here the 0 to t here. So that means 0 to that t1 is a 1 microseconds. Okay, 1 microsecond. So 1 microseconds here. P of t is a v of t. Okay, I of t. Okay, I of t dt. So plus, so this is also equal to 0 to 1 microseconds. So it is equal to v of t, I of t. So this is the dt values. Okay, got it? So now this value is equal to, so in this case, in the first plate, see, voltage is a constant. Okay, here voltage is a constant. But current is a increases. Here no need to write equation of the current. So directly you can calculate, right? Voltage is a constant. So that here 0 to 1 microseconds. So voltage is a constant means how much voltage value here? So here 600, okay, into I of t. Okay, I of t, so dt, okay, plus, so that is a 0 to microseconds. Okay, here in this case, in the second period, current is a constant, that value is equal to 100. So that is a 100. So that is a v of t. Okay, dt values here. So therefore simplify this equation, the 600, okay, is 0 to, okay, 0 to microseconds. Okay, I of t, okay, I of t dt. So place, okay, 0 to, okay, here this 100 is a common, 0 to microseconds v of t. So dt values here. This is the equation. So next calculate this one. Suppose here 600. So this value we can write into area of the curve. Average value. Okay, it is average. So area of the curve, area of the curve. Okay, with current equation. Okay, so next one, similar way. So plus 100, okay, into this integration you can write. So area of the curve. Okay, with voltage equation. Voltage equations here. So now calculate this value. So it is equal to 600 the into. So now this value is the area. Okay, here area of this one triangle. So that is equal to how much? The half into 1 microsecond multiplied by 150 here. So therefore you can write it is equal to 1 by 2 into, so 150 into 1 into 10 to the power of minus 6 seconds. Okay, this is a one value plus, so 100, so into, okay, this one, the calculate this area, okay, this part. So it is equal to how much? The 600, that is a 1 microseconds. Okay, so therefore it is equal to, okay, 1 into 100, so into half into the 600, so into 1 microseconds. Okay, this simplification you will get the 75 millijoules. Okay, got it? Like this we have to calculate. Okay, don't fear about the problems of the power electronics. Just attend the class, so you will get everything. I will give everything to solve the questions. Don't worry about it. Okay, got it? Very good. Like this we have to calculate the problems based on the power laws. Okay, here today we have discussed, there are the three formulas are very important. Okay, very important three formulas. So formula 1 is a P of T, so that is the instantaneous power. Instantaneous power, that is the P of T, it is equal to P of T into I of T. Okay, second one is energy. Energy is equal to integral of the P of T, okay, dt. So next third formula here, formulate, okay, third one is average power. Average power, so that is equal to 1 by T, the integral of P of T. Okay, these three formulas, most of the question comes from these formulas only. And one more, fourth one, so that is the straight line equation. Straight line equation with positive slope. Positive slope. So how do we get the straight line equation with a positive slope? So for example, V of T is equal to V into the T on or T of into T. So next one, the straight line equation with negative slope. So this is equal to, that is the V of T, okay, voltage decreases, the V into, okay, 1 minus T, the 1 minus T by T on, like. So these formulas are very important in this class. Okay, got it everyone? Okay, tomorrow we'll discuss remaining parts, the remaining classification of the power semiconductor device. That is also very important. Okay, so let's stop the class. So this is our Creatrix channel. So the Jain in this channel will get the all updates from the Creatrix. And next one, this is Unacademy GATE Telugu channel. So here we'll get the PDF class notes. Okay, class notes every day. So please join in these channels. And next one, some channels are there under the Unacademy. One is the Creatrix GATE, Unacademy GATE Civil, Unacademy GATE Telugu, SSC JE, Unacademy Computer Science. Okay, this is our channel, Unacademy GATE Telugu channel. So please the like, okay, like, the share and subscribe this channel. Okay, from the subscribe this channel to get all the notifications from this team. Okay, got it? Thank you all. Thank you very much. So tomorrow we'll discuss about the classification of the power semiconductor devices. The tomorrow topic is classification of power semiconductor device or switch. Okay, and also ideal VI characteristics. Okay, like, so we are every day we'll discuss problems based on this concept. Okay, as like today, so that is the topic, and also immediately some problems based on the topic. Okay, got it? We'll meet tomorrow. ఓకే, మీరు కంప్లీట్గా వీడియోస్ షేర్ చేయాలా, వాట్సాప్ పెట్టండి, వాట్సాప్ స్టేటస్ పెట్టండి, ఫేస్బుక్లో షేర్ చేయండి. మనకు ఆల్ ద తెలుగు స్టూడెంట్స్ రీచ్ కావాలా, అది మీ బాధ్యత. ఓకే, మేము ఎంత మీకు ఒక్కొక్క ప్రాబ్లం అర్థం కావడానికి దానిపైన పీపీటీస్ రెడీ చేసి చాలా వేస్తూ ఉంటాం బ్యాక్గ్రౌండ్ వర్క్. కానీ ఆ వర్క్ మీకు రీచ్ అవుతుంది అని అంటే కంపల్సరీ మీరు పీపుల్కి ఈ ఛానల్ని రీచ్ చేయాలి, అప్పుడే దానికి కరెక్ట్ ఉంటుంది. ఈక్వల్ బ్యాలెన్స్ ఉంటుంది. Am I right? Srikanth, Pavan, Ashavardhan, Nageshwar, okay, please share this channel to the maximum student they can utilize. Okay, ఈ కంటెంట్ మేము ఇచ్చే కంటెంట్ చాలా ఎక్కువ, సో అది కూడా ఫ్రీయే కదా, మీరు చాలా మందికి షేర్ చేయండి, యూజ్ చేసుకుంటారు వాళ్ళు. ఓకే, థ్యాంక్ యూ గైస్, విల్ మీట్ టుమారో.